Hey there, everyone. My name is Ryan Schul. Welcome to my data science channel. Today, I want to talk about analyzing unemployment data. Okay, so I became unemployed a little while back. It's not even a little while now, it's a long while. Back about 15 months ago at the end of 2023. I'm not sure what happened there, but my job just ended. There was some uncertainty about what happened. I don't know what that was, but anyways, the change was very abrupt, and there was no explicit reason or no explanation. It's just like, okay, the job is over. So that ended. I've been searching ever since. It's been pretty tough. Lots and lots of rejections, lots of interviews, but no offers. Um, so it seems like a weird time in the economy. In the all through 2024. Um, and I don't know what's driving this. Maybe some of it is AI. Maybe some of it is offshoring. I think some resources are being tapped offshore, and the American workforce is paying the price for that, right? So I've witnessed this firsthand. It's a little bit frustrating, but that's kind of how I came to create this YouTube channel. I had a lot of knowledge, experience, so on and so forth. Not a whole lot to do, so I had to channel my energy in a creative way, and I created this channel back in August. It took a while to get going, and I had to plan out some strategies and figure out how to execute. I didn't even know how to record a video at the beginning, right? I had to figure that out and how to post to YouTube. Um, so it took a little while to get going, but yeah, now I'm up to like 215 videos and keep cranking them out. So I think when you do create YouTube content, it helps you to really focus on whatever topic you're working on. Right now, it's unemployment data, right? And you really, really, really have to understand the topic, whatever you're explaining, or your channel has to be very entertaining, right? I think there's two ways to make money, or two ways to be successful on YouTube. Either take an educational route. That's what my option has been. That was my choice, to be all about education. And I think if you're very entertaining, that's another way to make money on YouTube. I think those are the two primary ways. There's probably like little offshoots of those two. I think those are the main pillars of successful YouTube channels. Okay, so if you're interested in checking out this kind of lifestyle, make your make your YouTube videos either educational or entertaining. I guess if you can do both, you hit the jackpot there. Maybe somehow. I don't think that data science is very entertaining. I think it's very educational though. So hopefully you agree with that assessment. We'll see. Um, Still trying to get the stats up for my channel, number of subscribers and number of total hours viewed. So that's a work in progress. So, anyways, we're looking at unemployment data, right? Trying to predict future unemployment patterns and trends. Try to understand if there's some kind of policy or analysis or planning. Is there some kind of strategic change in the economy at the government level? Has there been new legislation enacted that could cause unemployment? Um, like I said, I think AI is driving some of it. Offshoring, tapping resources in cheaper areas can create unemployment patterns in the United States, right? There could be geographical or demographic patterns or trends, right? Maybe on the East Coast, things are humming along. Maybe on the West Coast, it's not quite as rosy. Maybe it's vice versa, right? So geography can play a factor. Um, so we'll try to take a look at each of these. We'll try to get to whatever we can. Like sometimes you just don't have access to this data. I searched around for quite a while for the data, and I found a very useful resource right here at the St. Louis Fed. So if you copy and paste this over here, you can go ahead and create your own API endpoint or API key. Okay, you'll create an account. If you use this URL right here, it should take you to a page. Now I already have an account, right? So it just takes me straight to my page. But it should ask you to create an account if it doesn't exist, and you can see API keys over here on the left. Okay, so I can't share my API key with you. This is personal and confidential, but you can go ahead and get one for free. Just takes like a half a minute or whatever, maybe a minute if you're kind of a slow typer. It's pretty fast though. Once you get your key, you can pop it in right here, and you can do all the analysis that I did. I'm not going to run this because I just put in this page holder, or what is it called? Like not page holder, placeholder. Yeah, placeholder. Put in this placeholder for where you would enter your API key. But again, I can't expose mine. I can't give you that. So just go ahead and get your own. It's quick and it's free. So when I got to the St. Louis Fed website, I found some things that looked pretty interesting. GDP growth rate, inflation, federal funds rate. Uh, that's the rate that banks lend to each other. I think the overnight rate. I think that either tracks it or it's basically the same thing. Labor force participation rate, consumer confidence index, wage growth, and unemployment rate. So they have all of these features, right? In the data science world, a feature is a column of data. So they have these features, and I want to try to analyze and understand, are these features connected to the unemployment rate somehow? Do they impact the unemployment rate? Is there high correlation, no correlation, and so on and so forth? So again, go ahead and grab your own API key. It's pretty quick and pretty easy to get that set up. Pop it in there and then run this code, and you will get this nice looking data frame. Okay, the code is pretty self-explanatory. You're pulling everything into one consolidated data frame, all right? So you're getting these different columns and appending everything together or concatenating it together. They actually do come from different sources, so I don't think there's any one source where you go where you can go and get everything. But when you use this technique, you can pull it into your environment, you fetch the data, and then you organize that into a nicely structured data frame, right? So originally it comes with 938 rows of data. You can see that these rows come in monthly, so it's the beginning of the month, the first day of each month. Whatever the number is, it's reported here. And I actually put in one line of logic here to say if unemployment rate is not equal to 0, then copy everything to a different data frame, right? So I'm creating the combined data frame with everything consolidated together. And because I'm studying unemployment, I just want to make sure that there's no zeros in the data. So it went from 938 to 926 because I think for several months at the beginning, data was available for some of these other categories, but not for unemployment numbers. Okay, we didn't have those. So we dropped about, what is this, like a few records here. It's no big deal, right? So we have 926 legitimate months going back in time into 1948, right? So pretty deep history. I think this is a good start. And then the first thing I'm doing right here is just taking from the F final into the F unemployment, 2 columns of data. I want the date and the unemployment rate. I'm going to pop that into profit. So this came out of Facebook a few years ago. This is a great tool for forecasting and making predictions into the future. I want to predict what do the future unemployment numbers look like potentially. Okay, we know in the past exactly what it was, and we can take that past historical trend, whatever it is, and forecast it into the future. So profit is great for doing these types of things, for predicting anything that's a time series, basically any kind of stock price change. If you're trying to predict the growth of your business, demand from customers, sales as your business, anything like that, right? So DS is going to be the date. Y hat is the variable that we're predicting. We can ask profit to give us a lower Y hat and an upper Y hat. Okay, and the reason we do that is because we want to set these sort of confidence intervals and have like an upper and lower threshold and say, okay, most of the time I want the numbers that come from the forecast to be within these upper and lower bounds. So you set some guardrails or some sort of regulation about how profit can make these predictions. And I'm making a prediction for the next 365 days. So remember, when you look at this data, it comes in monthly on the first day of the month. We don't want to make only 1 month's worth of predictions. We want like several months, probably. I asked it to do 365 days. That's 1 year. And the profit tool will generate forecasts on a daily basis. You can convert that to weekly, monthly, annual if you have a very deep history, whatever you want. But by default, all of the predictions come back daily. And if you think about that's what you want to, because a lot of times these predictions are going to come in daily, but are unemployment numbers going to be checked or updated or even analyzed daily? No, of course not, right? But the model by default will forecast daily dates. So this is the prediction here. Right here. So it is March, what is the date? March 18, 2025, and it's making predictions into the future. So we can see January 2026, and there's the daily date, right, with the most likely Y hat, and then the lower. and then the upper, and I plotted everything in this nice chart too. Okay, so I think that works well. I want to go ahead and look at all of these. I wouldn't call them economic indicators, but all of these metrics or indicators over a period of time going back to, I think, in 1948. That's when the Fed started collecting this data. And I don't think it collected all of these actually, but it did collect most of these. Some of these metrics started a little bit later than 1948. So this one is kind of dominating here, GDP growth. The thing I really love about these plotly charts are that it's very interactive. You can click on any thing over here and turn it on and turn it off, and it's going to be displayed or hidden from you. So GDP growth, I think, is important. I do want to look at that, but since it's dominating the graph, I'm going to take that off. This one, I think it came in almost daily or something. It came in high frequency, maybe week ending, and that's pretty choppy. And then it got to be, I guess, more monthly because we saw this is beginning of month data. So I'm just going to take that off too, because that's just getting a little bit confusing. And what we're left here is inflation, which kind of dominates the graph. If you take that off, it's a totally different perspective here of what's happening. So inflation from 1950, it went from basically 0 up to over 300. So that is a real eye opener. I didn't know it was that high. I knew it was high, but I didn't know it was 300%. But yeah, that's a big number right there. And you can see during COVID, it really jumped up quite a bit, right? So one thing that's nice about these plotly charts is you can zoom in, you can zoom out, you can see all the details if you put the mouse over it, things like that, right? And you can interact with the chart pretty easily over here too. So, okay, so we have our indicators here. Let us do some basic analysis and start to see like what actually impacts the unemployment rate, if anything here, okay? Maybe there's no impact, maybe there's some. Let's discover what's going on. So I put everything into a correlation matrix to see, okay, what features here are highly correlated with unemployment. Okay, so if I look at unemployment, this is the last column over here. This is 0, this is low, 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 and low. There's basically no correlation between any of these features and unemployment. There is some correlations between wage growth and inflation. So that tells me as inflation is increasing, wage growth is increasing. There's a negative correlation between wage growth and federal funds rate. And I think that makes sense too. So the federal funds rate basically is banks lending money to each other or applying for some type of loan, right, for your house, for your car, or commercial loan if you're a commercial real estate developer or whatever, right? When you're borrowing money, it's going to, the interest that you pay is tied to the federal funds rate. So that's interesting, right? So as wage growth increases, the federal funds rate decreases and vice versa. As federal funds rate decreases, wage growth increases. So, and you see a big positive correlation between wage growth and inflation. That's the 0.82 over here, right? So that's pretty high. And other than that, there's not really any huge, oh, this is a little bit high. So anything over 0.7, correlation of 0.7 or higher is considered statistically significant. So labor force participation rate and what do we see? Consumer confidence index, that has a high correlation. So as more people are in the workforce, consumer confidence is boosting up. That makes sense, right? If consumer confidence is waxing and waning and decreasing, labor force is probably following suit, right? And you'll have more unemployment. But actually, there's a very low correlation between labor force participation and unemployment. That's only 0.25. I thought that would be higher, but it is not, right? And this is what it is. That's why we do the analysis. You can't make assumptions about the data. You have to do the analysis and see what actually, what the truth is, what the real story is. Let me cut that out. And by the way, that's how I came up with the name for this channel, Straight Data Science it's called, because in every single video that I've put out, I think it's up to like at least 215 videos now. Every single one is honest truth and straightforward. You know, this is how it's done. This is the analysis. This is my findings and so on and so forth. None of this is fake or, you know, or what just made up fictitious, right? Like straight data science is just straight up the truth. And this is how it works, right? Like I thought unemployment and labor force participation would have a high correlation. It's actually very low. So that's the truth. And it's kind of weird. I think, based on my knowledge, my understanding, I thought it'd be higher, but it's not, and that's fine. We're looking at the truth here, okay? So the truth shall set you free, right? Okay, so let's look at a basic linear regression model to see if we can use this model to make predictions on unemployment rates and we're going to look and see what independent features, right? These are all the independent variables, what independent features could have an impact potentially on the unemployment rate. So this is the dependent. Remember, in machine learning, we always have the independent features, which are either one or multiple features. In this case, it's multiple. Usually it's multiple. And then you'll always have one target variable that you try to predict. Okay, so this is the target. And I did the analysis, and you can see down here in my notes, the findings were as follows: 0.126 R squared, so very low R squared. 12.6% of the variation in the unemployment rate can be explained by all the predictors comprehensively, right? So we look at everything, we throw this into sort of a big blender or mixing bowl or whatever you want to call it, and see collectively how do all these factors impact the unemployment rate. And it's really not a big impact for all of these simultaneously, but we'll see that there are some significant statistical impacts from some of the features themselves. Okay, so this model basically has very low explanatory power. You can't look at all these features. So wage growth, consumer confidence index, labor force participation, federal funds rate, inflation, and GDP, and predict unemployment. But we can use a couple of the features to make those predictions, right? So inflation has a very small p-value. This means basically anything less than 0.05 is statistically significant. And this will affect the unemployment rate. So high inflation can have an impact on unemployment. And we're saying we're living through a very high inflation environment right now where the prices of everything is going up continuously with no end in sight. And you see high unemployment, right? So that totally makes sense to me. There is a statistical evidence, significant statistical evidence, 0.000. The lower the p, the better, right? The stronger the relationship between inflation and unemployment. GDP has no impact on unemployment whatsoever. So remember, 0.05 and less, there's a significant relationship between the two, and 0.05 or greater, there's no relationship, right? Really, right? So this is greater than 0.5. GDP and inflation have no relationship. 0.63, no relationship. 0.0. So labor force participation rate, even though it's not highly correlated, right? There's no correlation, but this variable has significant predictive capabilities when you use this to try to predict the target variable, right, which is unemployment. So that's interesting. So correlation is an interesting analysis to do, but that's certainly not the only one, right? So we have to look at this stuff from several different perspectives and really understand what's going on. The correlation could be high and p-value could be high, vice versa. One could be high and one could be low, right? You have to do this analysis and see how things shake out, because just by looking at the data, you're never going to guess. You're never going to guess what the outcome is, right? You have to do the work and then interpret the results. So labor force participation rate and unemployment have low p-values. So those both these features are good for using as predictors of the unemployment rate. And consumer confidence, nothing there, right? Greater than 0.05, so nothing. And wage growth. Okay, so this makes sense too, right? Wage growth and unemployment have a statistical significant relationship, and that is to be expected, right? So I captured all that in my notes here. Let me cut this out. I don't actually need that. That's just a blank cell. It's literally nothing in it. So in the next thing right here, I plotted some historical trends of unemployment rate and plotted that on the chart. And then I just added a small rolling mean so we can kind of adjust for that big spike that we saw back in March of 2020 when so many people were getting laid off, right? And unemployment claims were spiking up. Remember, and we saw exactly the same thing over here in this chart. If I turn this off and turn off inflation, I don't need that. I don't need that one. Yeah, I don't need that one. And I don't need that. So now we're just looking at two federal funds rate and unemployment rate. And then if I just take this one off again, we'll see that big spike back in March of 2020, right? That's the unemployment rate. So you see essentially the same thing right over here. With a lag, I added or a mean, sorry, added a 12-month mean just to kind of smooth that out a little bit, because you do see some big spikes. You see one over here, a couple of smaller ones over here, but this COVID one really dominates the whole chart over here. So I took a look at that. This would be the linear trend. So over time, it's just about 6% over the course of time. It's around 6%. That's really the median. But you can see it fluctuates wildly above and below that 6% line. But going back to, I think this was what, 1948? I think going back to 1948, that was the overall unemployment rate has had an average of about 6%. I thought that was interesting, so I included that. And you can look for short-term trends. I don't see any short-term trends here. Long-term trends. This does tend to be cyclical with these peaks and valleys occurring over and over. There's unemployment. There was an unemployment spike during COVID, obviously. Not quite as recent, but still pretty dramatic, was the 2008 financial crisis. Another pretty significant impact was the dot-com boom and bust. The bust happened, I think, in March or April of 2000, I think. You could Google it. I think it was around March of 2000. The dot-com thing blew up in our faces, and there was a lot of unemployment. So these things tend to be cyclical in nature, but usually they work themselves out, and people recover and get back to work pretty quick. So that was most of it. I found this online. I thought this was kind of interesting too. This is FIPS data, which is basically county level data. So all the counties across the United States. So all the counties in every state. I live in New York State. We have Queens County. That's the county I live in. We have Kings County, also called Brooklyn, New York. What else? There's a couple counties out on Long Island. Upstate has a bunch. I think New York has like 20 something, 25 or 26 counties across the state. If you get out to the West Coast, you'll see significantly more, right? Once you get out to California, you see all the counties over here. So this is giving us the unemployment rate by county. So if you zoom out, you can see the state borders and kind of make that out. But I thought this map was very interesting because you can see little pockets of higher unemployment, right? And it does seem to be geographical and regional. I guess in some places, there's just not too many opportunities to find a job. This is probably an undeveloped area. It looks like West Virginia, maybe. Coming over here, you have something on the border of Canada that's probably very remote area, probably remote, probably not a lot of work for these people to do, if any. It's a little bit, I guess 12%, right? So anyways, I thought this map was pretty interesting. The darker colors are good, right? Less unemployment, and lighter colors are bad. You have more people out of work, consuming resources, but not helping out with the provisions for the rest of the members of the tribe, right? So that was it. We found a couple of features that had a statistical significant impact on predicting unemployment rates, right? So I summarized all that in my notes. That's over here. Hopefully that was enlightening and interesting. We found inflation, labor force participation, and wage growth, and those I think are three that can be kind of predicted. But again, you kind of have to do the work. You can't just look at the data and say, "Oh, well, it's probably this, probably that." You can hypothesize, and it's great to come up with a hypothesis, but you still have to do the full analysis to really understand how is the data speaking to you. What is it saying? What's the story? Can you prove your hypothesis? Yes or no? And if you can't, then you have to change your hypothesis, right? Because the data is data. It's not going to change. It sounds kind of crazy, but I'll say it anyways. Like, you would never change the data to match your hypothesis. You come up with a hypothesis, and hopefully the data matches. If not, then you have to restate your hypothesis. But you would never change your data to match a hypothesis. You run the analysis and hopefully prove your hypothesis. If not, then you have to change your hypothesis. Okay, that's how we do it. So that was it. And this map is kind of cool. You can zoom in, zoom out, and I like how it's dynamic. You can put the mouse over and shows you the details of each state county, all the counties within all the states all across the U.S., and then the unemployment numbers. So that's my findings in a nutshell. Just wanted to share that with you guys. And that's pretty much it. So I'm going to wrap it up here, and I will see you in the next video. Take care.